Hi there! Welcome back to the Back to Basics series. Ever wonder what's actually happening inside a wire when you flip a light switch? What is electricity really? People knew about electricity since a very long time, but although they observed the related natural phenomena, they didn't know how to explain them. They could see a thunderstorm and a lot of lightning, but they didn't know what lightning was, and so they attributed it to angry divinities that used the thunderbolts to punish bad people. They could also stroke a bar made of amber, and they would see it attract light pieces of other materials, but they didn't know why that was happening, and so they attributed that phenomenon to magic. It was only in the 19th century that humanity finally got a better understanding of electricity. They understood the physical principles behind it and learned how to use it, first for their own pleasures, and then for actually do some work to help themselves. And finally, we learned how to use electricity to do the most incredible things: light up our houses, create radios, TVs, computers, robots, and everything you can think of today. If you would like to understand more about electricity and maybe one day be able to bend it to your will, just follow me in this series of videos. Through that, you will learn the concepts like voltage, current, resistance, capacitance, inductance, and so forth, and you will learn how the devices around us are made of, and about the electronic components. And moving forward, you will learn how to build new things out of those components, and who knows, maybe one day you will be the great inventor that will revolutionize again our society. Let's start today with some basic concepts: voltage and current, and how they are related to each other. What is voltage? Think of it as of some sort of energy that moves things around. The typical example is a river that flows down a hill. The height of the hill from which the water flows represents the voltage, which is measured from the bottom to the top of the hill. The higher the hill, the higher is the potential energy of the water, and the higher is the voltage. If you'd like to go a little deeper on the concept of voltage, please watch a previous video of mine titled "What is Voltage?" The link is coming up now on the upper right side of the screen. The current instead is made of all the droplets of water that flows down through the river. Such droplets, in terms of electricity, are called electric charges. The height of the hill is the same as the voltage of a battery. The wire connected to the battery is the bed of the river, and the water that flows in the river is the electric current in the wire. The higher the hill, the more water will flow down the river. The higher the voltage of the battery, the more electric current will flow in the wire. For more details on the concepts of current, please watch my old video titled "The Electric Current Explained." The link is coming up now in the upper right corner of the screen. We measure the voltage in volt and the current in ampere. We usually represent these measurement units with the letters V and A, and we can measure these entities with instruments that are called voltmeters and ampere meters, or ammeters for short. Just like we measure the height in meters and the amount of water that flows down the river in liters per second. Well, yes, in US people is more accustomed with yards and gallons rather than meters and liters, but you get the point. In more precise terms, volt is the ratio between the potential energy provided by a battery and the amount of charge needed to generate it. Current, on the other hand, is the amount of charges flowing through a section of the wire in 1 second. Back at the beginning of the 19th century, an Italian scientist named Alessandro Volta was conducting experiments on frogs. He discovered, inadvertently, that touching a dissected leg with 2 metal sticks made of 2 different materials, the leg contracted, as if it was alive. Curious about what happened, he started experimenting with different metals and different watery solutions, mimicking the fluids in the frog's leg. Soon he discovered a way to generate electricity. He just invented a battery, which he called pile, since it was made of a pile of metal and paper discs moistened with an acidic solution. Today we call that device a voltaic pile made of several voltaic cells to honor the inventor of the device that revolutionized our civilization. After that, other people started experimenting with this newly found source of electricity, and names like Georg Ohm and André-Marie Ampère became famous in that same century. Yes, just about 200 years ago. In particular, André-Marie Ampère found a way to measure the current flowing in a piece of metal when a voltage was applied to it. Georg Ohm, instead, used the voltaic pile to run experiments on different kinds of materials to figure out how they behaved when in the presence of a voltage. He prepared a set of metal bars of different materials and same section, connected each bar to the pile, and measured the amount of current that was flowing through. Then he changed the voltage applied to the bar by increasing or decreasing the number of cells in the pile, and with that he discovered that for the same bar the ratio between voltage and current, whatever the voltage was, never changed. He called this ratio the resistance of the material, and he further discovered that different materials have different resistances. Today we have named ohm the measurement unit of the property he discovered, and we represent it with the Greek letter omega, which sounds like the initial of the name Ohm. We write that the voltage V and the current I are directly proportional as per this formula. V over I equals R, where R, the resistance, is the constant of proportionality. In terms of their measurement units, we also write that volt over ampere equals ohm. This is what we call Ohm's law, which is the foundation for the calculations of voltage and current in any electric and electronic circuit. Ohm's law can be expressed in any of these forms depending on what we need to calculate. V over I equals R, V equals I times R, I equals V over R. As you can see, the three concepts of voltage, current, and resistance are not independent. They are all linked together by the fundamental principle called Ohm's law. On the same resistance, more voltage causes more current to flow, and with the same voltage, a higher resistance allows a smaller current to flow, and with the same current, a higher resistance causes a higher voltage. I hope this helps demystifying the very basic concepts of electricity. If you found this useful, please hit that thumb up and subscribe for more Back to Basics videos. In the next episodes, we will go deeper into these concepts. We will learn how to measure these entities, we will learn about electronic components, how to use them in circuits, learn how to read schematics, and so forth. Please let me know in the comments what concepts you are more interested in, so I can better aim this series of tutorials to your likes. Thanks for sticking around till the end of the video, and to celebrate Ohm's law, I'm giving away 5 of these awesome mini voltmeters. They are super useful for any electronics hobbyists or for your next science project. To enter, all you have to do is answer 2 simple questions related to today's topic. Here is question number 1. According to Ohm's law, if a circuit has a resistance of 6 ohm and a current of 2 amps, what is the voltage? And here is question number 2. What is the name of the Italian scientist who invented the voltage generator used by Georg Ohm in his experiments? Put your answers in the comments below, and here are the rules for the contest. You must be subscribed to this channel to win. Leave your answer to the questions in the comments section. Only 1 entry per person, please. The deadline for entries is October 30th, 2025 at noon, US Central Time. Winners will be proclaimed during Halloween's night. What a better treat than that? I'll be randomly selecting 5 winners from all the correct answers and announcing them on my Facebook and Patreon pages, as well as in a pinned comment right here on this video. The winners should contact me privately with their actual name and address so I can send them their prize. Good luck everyone, and thanks for watching. I'll see you in the next episode, and in the meantime, happy experiments!